Let's continue the question. Page 203, question 6. In an experiment to measure the speed of sound in steel, a steel pipe of length 200 meters is struck at one end with a hammer. A microphone at the other end of the pipe is connected to an accurate timer. The timer records a delay of 544 seconds between the arrival of the sound transmitted by the steel pipe and the sound transmitted by the air in the pipe. The speed of sound in air is 343 meters per second. Calculate the speed of sound in steel. Okay, so what do we have here? Look here, please. I have a steel pipe. Here's the hammer, the source of sound. Here's the timer is here. So here the sound will transfer or travel in two ways. First of all, through the steel pipe, solid. Second, through the air in the pipe. Okay, the pipe has air inside, so also through the air. They want you to find the speed of sound in steel. Now what do we have? They gave you the distance. Now this distance, it is the distance of sound waves travel by air and the distance of sound waves travel by the pipe. So the same distance for air, the same distance for solid or steel. They said that the timer records a delay of 0.544 seconds. So I have difference delay between the sound arrival by steel and by air. Now speed of sound is given 343 meters per second. To find the speed of sound in steel, what do we need? Speed of steel, we need distance, it's given 200 over time. Now the time, it's not given. They give you the delay of time. The time here is not given. So what we can do, from where we can find it? I will tell you. Now the speed of air is given and the distance is given. So what do? We find the time it takes for sound to travel through the air, and we have the difference between air and steel, so we can find the time for sound wave through steel. Step by step. So speed of sound in air equals distance over time. Distance is given 200. Here is it. Time, I want to find it. Speed of air is given 343. So here is the time. This is the time taken by sound in air through the pipe. The air inside the pipe. So the time taken by sound in steel. And steel is what? The speed of sound in air minus the delay, the difference between the two times. We can get the answer for what? For the time taken for the pipe, a time taken by sound in steel. We use this time with the distance to find the speed of sound in steel. So the answer is 5,128 meters per second. And it's a correct answer. Why? How do you know? Now, I told you before that the speed of sound in solids 5,000, 6,000, 7,000, within this range. Speed of sound in air 300, in water 1,000, and so on. Clear?